Hey everyone, this is your second Ratios and Rates unit lesson. This one is on rates, and rates are things that we use every day. We use them in the grocery store or any store we go to when we're buying things. We use them when we are driving and we're looking at our speed. We use them when we are filling up our gas tank and trying to figure out how many miles do we get for each gallon of gas. So rates are all around us, and we use them in a lot of different ways. We use them in sports and a whole bunch of other ways too. So one example of, first of all, a rate is a ratio. We're still dealing with fractions here that compare two different quantities. So things like miles and gallons. Miles and gallons are very different quantities. Miles are distances, and gallons are a measurement of liquid, right? So when you're looking at your car and you're trying to figure out how many miles can you drive for every gallon of gas, each car has a different value for that. So a hybrid will have a much higher value than a giant pickup truck, for instance. A very helpful kind of rate that helps us understand the world around us is a unit rate. A unit rate, the word unit is the trick there, has a denominator of 1. And I'll explain what I mean by that in a second once we fill in the next blank. To change a rate to a unit rate, all you've got to do is divide the top by the bottom, the numerator by the denominator. What I mean by this is if you're driving down the highway, you are going 65 miles per 1 hour. 65 miles an hour. If you're driving for 2 hours, that's 130 miles in 2 hours. No one measures speed that way. You don't say I was going 130 miles for 2 hours down the road. You always do it in terms of 1 hour. So unit rate is something that we use a lot, including in the grocery store. So we are going to write rates using the fraction symbol. So it'll be something up here and then something down there. This is read as per, miles per gallon, okay? But suppose we're talking about Burke. This is actually a terrible example because this is not true of Burke. But let's express each rate as a unit rate, and then round to the nearest tenth when necessary. So if there are 175 children and they're divided up into 5 classes, how many children are there in each class? We will start by writing a ratio. 175 children in 5 classes. If we take a calculator or do long division and we divide that, that gives us 35 children per class. And I have to make a correction, actually, I just realized. I'm going to come back to that in a second. What we're actually doing is using the slash symbol to indicate per. I misread my guided notes, and I apologize. So if we have 175 children in 5 classes, we write it as a fraction, and then we just divide the top by the bottom, and that's 35 children per class. So let's look at an example. Let's do brownies. That sounds fun. We have 138 cups of flour. That's a ridiculous number. Used in 46 dozen brownies. So we're talking about like a bakery here, right? Not our home, hopefully. You have 138 cups of flour in 46 dozen brownies. I cannot divide this in my head, but if I grabbed a calculator and divided it, it would turn out that that gives you the number 3. 3 cups of flour, because this is the cups up here, in a dozen brownies. So 3 cups per dozen. The order here matches the order here. Cups in dozen, cups per dozen. Let's try one with a fraction because no one likes working with fractions, I get that, but let's try it anyway. Ben walked for 8.5 minutes and covered 3/4 of a mile. What's his speed in minutes per mile? So 8.5, let's go ahead and make this into an improper fraction. 2 times 8 is 16, plus 1 is 17 over 2. 2 times 8 plus 1, and you keep the same denominator. And the other fraction's already in a regular fraction without a mixed number, so we're good. We're going to take that top fraction and divide it by the other one. So 17 over 2 divided by 3 over 4. You may have forgotten how to divide fractions, so let me remind you. You take the top one, and then instead of dividing, what we're going to do is we're going to take this bottom fraction and we're going to flip it, but this time we'll multiply. So division becomes multiplying as long as we flip the bottom fraction. Now what we can do is do a little bit of canceling, or we can multiply and simplify. 4 up here and 2 down here, I can divide each of those by 2. And what that does is it gives me an answer of 34, because of the 17 times 2, over 1 times 3. Actually, you know what? I'm going to show you another trick. You don't even need to simplify because we're going to divide afterwards anyway. 17 times 4 would be 68. 2 times 3 is 6. And when we divide that using a calculator, we'll end up with about 11.3 minutes, I'll abbreviate minutes, per mile. We will not often be using fractions, but it's good to know how to use them just in case. Let's look at an example with a table down below, and then we'll look at some with price in the next page. Here, the table shows the number of cupcakes made by each of the 4 bakeries each day. Cakes and cupcakes, my bad. Which bakery makes most cupcakes per cake? So cupcakes per cake means cupcakes up top and cakes on the bottom. This is a little bit annoying because you have to write a bunch of little fractions here in the small space. Cupcakes per cake. So I'm going to take that number and I'm going to divide it by that number. That's going to give me approximately 12.9. And if I divide 400 divided by 35, that's going to give me 11.4. This is a silly example because I don't know why you would ever actually do this in real life, but at least cupcakes and cakes are fun. If we divide that, we get an even 15. And you don't have to write out these fractions. I'm doing it to show you where the numbers are coming from. You could just grab a calculator to do it and get 12.8. So which one of these has the highest number? That would be 12.9, which is, nope, that's my bad. I was looking at the decimals and not paying attention to the numbers. 15 is higher than all of those. 15 is our highest, which means Tamira is our winner. So I'll write down Tamira next to it. You can do the same thing for number 8, where this is more makes sense for number 8. You're looking at these 4 athletes on the track team and dividing time divided by miles. And then you're trying to see who's fastest. Let's do just a couple more problems on the next page. We are almost done. This is really relevant because you want to save money when you're shopping for things, right? So unit rates with price. Unit prices give the cost for 1 unit. And when you're comparison shopping, whether you're at Costco or at Safeway or at Whole Foods, it helps you find the best deal. So to do this, and we'll just do 2 problems together, we will always divide the price by the quantity, so how much we get. So we'll look at a couple of examples to make this make sense. Let's look at expressing it as a unit rate, and then we'll do some comparison shopping below. 6 feet of ribbon for $19.20. So we're going to divide the price by the quantity. This is really important up here. The price should always come first, and the number goes underneath. So my price is $19.20, and how much am I getting? 6 feet. So if I divide that, I'm going to put my money symbol up top, dollar sign, I don't know why I call it money symbol, but that would give you, when you divide, $3.20 per foot. Money per foot. For number 11, if we're looking at pencils, because we're buying pencils for school, we'll take that price of $1.44 and divide it by 12. If you know your times tables, this one's not too bad to solve in your head, but you could grab a calculator. That ends up being 12 cents per pencil. The same for all of them. Money comes up top. The price goes up top. So if you look at all these problems, they're written in different ways, but the money always shows up on the top of the fraction, so we can figure out how much per item. This will give us one more problem to do, How do we know what's the better deal? We are pizza shopping. We want to know how to get the most pizza for our money. 15 pizzas for $1.95. So how much is that per pizza? Let's divide. Take the cost, divide by how many we get. That gives us $13 for each pizza. Let's find out if the other option is better. Let's look at $120 divided by 10. This one's easy to divide because you can just cancel. This is going to be $12 per pizza. Now we're ignoring pizza quality here and your favorite pizza preferences, but if you're going strictly for cheapest pizzas, option B is the winner because it is less per pizza. Same for all of these. Take the price, divide by how many you get. That's your unit cost. And then you can compare for each one. To end this really quickly, if you're at the grocery store and you're buying, say, toilet paper, and you can buy 1 roll, or you can buy 6 rolls, or you can buy 12 rolls or 24 rolls, all those cost different amounts, obviously, because you're getting different amounts. If you look at the rack, it'll actually tell you in the corner of the price tag what it costs per roll or per sheet, is I think usually how it works for toilet paper, and you can look to see which is actually the better deal. So we'll talk more about that in class, but I wanted to give that one example first.